Hello everyone, welcome to Indian Institute of Information Technology, Vadodara, International Campus, CU. We are here to explain you the experiment, the study of phase change. I would like to say you the aim of our experiment, to study the phase change of a substance from liquid to solid by plotting the cooling curve, to determine the melting point of a given substance and find out the transition time. Understanding the transition time and how it behaves when the surrounding temperature is above the melting point. To study the relationship between the surrounding temperature and the transition time, to understand the change in transition time for different masses at constant temperature, to understand the change in transition time for same masses at different temperature. Now I request Vishnu continue with the theory.
Theory. The term change of phase means the same thing as the term change of state. The change of phase always occurs with a change of heat. However, the temperature does not change. But when we heat a solid, the energy supplied is used to increase the kinetic energy of its molecules, and thereby its temperature also increases. Energy is required to melt a solid because the coercive forces between the molecules must be partially overcome to allow the molecules to move about. Energy is required to vaporize a liquid because in so doing the molecules are separated and molecular attractive forces are overcome. But there is no temperature change until a phase change is complete. The quantity of heat absorbed or released when a substance changes its physical phase at constant temperature. Example, from solid to liquid at melting point or from liquid to gas at boiling point is termed as latent heat. The quantity of heat absorbed or released when unit mass of a substance changes its physical phase at a given temperature is called a specific latent heat. The constant temperature at which melting or boiling takes place is known as melting or boiling point. Let us understand all the theory given in the clear way by using the graph and recall all the prerequisites. Okay, see here from solid to liquid, the term is called as the change of phase of the change of state is called as melting, and from liquid to solid it is called as freezing. At the same way, from solid to glass it is called as sublimation, and from gas to solid is deposition, and gas to liquid is called condensation, and liquid to gas is called vaporization. And also gas to plasma is called as ionization, and finally plasma to gas is called as deionization. Newton's law of cooling. The Newton's law of cooling states that the rate of change of temperature of an object is directly proportional to the difference between the temperature of its surroundings and its temperature and its own temperature. A cooling curve is first plotted between a substance of graph of variation of temperature with time, and the substance is allowed to cool. The gradient of the cooling curve is related to the heat capacity, thermal conductivity of substance, and external temperature. It is related as dt by dt equals to minus k into T minus T naught, where T is the temperature of sample, T naught is the room temperature, and K is the positive constant. Here, the graph is plot between the temperature and the time. The upper part of the highest temperature is called as pouring temperature, and the slope is called as cooling rate, and the constant is thermal arrest, and the point where the thermal arrest is completing, the point is known as the equilibrium freezing temperature, and then the time goes on, the temperature will also get decreases. Firstly, we have taken three substances. One is ice, and second is naphthalene, and third is wax. We have noted the change in transition time with the change of temperature for each substance, and also by changing the mass of each substance, we have noted the transition time and change of temperature. Firstly, we discuss about naphthalene.
That's really cool. Firstly, we have taken 10 grams of naphthalene and found out the transition time for different temperatures like 0, 25. 50, 75, and 100 degrees centigrade. Firstly, we have taken 10 grams. After noting down all the transition times of same mass, we have changed the mass to 30 grams and 50 grams and found out the values for 0, 25, 50, 75, and 100 degrees centigrade. The naphthalene I have taken is in liquid state at 218 degrees centigrade. The first step, we have taken the mass of naphthalene as 10 grams and the surrounding temperature as 0 degrees centigrade. And we found out that the transition time of 10 grams of naphthalene is 6.57 seconds when the surrounding temperature is 0 degrees. The curve remains flattened in the transition time, and I found out the curve remains flattened at this point. And also, the melting point of naphthalene is 80.26 degrees centigrade. During the second step, we have kept the mass of substance constant as 10 grams and increased the surrounding temperature to 25 degrees centigrade. And we found out that the transition time of 10 grams of naphthalene is 7.428 seconds and the surrounding temperature is 25 degrees. The curve remains flattened in the transition time. Even during the third trial, we have kept the mass of substance constant as 10 grams and increased the surrounding temperature to 50 degrees centigrade, and we have found out that the transition time of 10 grams of naphthalene is 8.538 seconds when the surrounding temperature is 50 degrees. The curve remains flattened, the transition time, at this point. During the fourth trial, we have kept the mass of substance constant as 10 grams and still increased the temperature of surroundings to 75 degrees centigrade. And we have found out that the transition time of 10 grams of naphthalene is 10.032 seconds when the surrounding temperature is 75 degrees. The curve remains flattened in the transition time, and I have found out that the curve remains flattened at this point. This is the most peculiar observation I have taken till now, where the surrounding temperature 100 degrees is above the melting point 80.26 degrees centigrade. The transition time of 10 grams of naphthalene is 12.156 seconds when the surrounding temperature is 100 degrees centigrade. The curve remains flattened in the transition time. Here, the transition time is a point where the substance is in equilibrium, and I found out that the curve remains equilibrium at 102.6 degrees centigrade. Then we have taken 30 grams of naphthalene and found out the transition time for different temperatures like 0, 25, 75, 100 degrees centigrade. During the sixth observation, I have taken mass of substance as 30 grams. I have increased the mass from 10 grams to 30 grams. Surrounding temperature as 0 degrees. The transition time of 30 grams of naphthalene is 6.582 seconds and the temperature of surroundings is 0 degrees. The curve remains flattened in the transition time, and I have found out that the melting point of naphthalene is 80.26 degrees. During this seventh observation, the mass of substance is 30 grams and the surrounding temperature is 25 degrees. The transition time of 30 grams of naphthalene is 7.434 seconds when the surrounding temperature is 25 degrees. The curve remains flattened in the transition time. I have found out that the curve remains flattened at this point, where the curve reaches the melting point 80.26 degrees. During this eighth observation, I have taken the mass of substance as 30 grams. The surrounding temperature has been increased to 50 degrees, and I have found out the transition time of 30 grams of naphthalene is 8.538 seconds when the surrounding temperature is 50 degrees. The curve remains flattened in the transition time. The curve reaches transition time at this point, where it reaches the melting point, which is 80.26 degrees. During this ninth observation, we have increased the surrounding temperature to 75 degrees centigrade and they found out that the transition time of 30 grams of naphthalene is 10.032 seconds when the surrounding temperature is 75 degrees. The curve remains flattened in the transition time, and the curve remains flattened at this point. This is another peculiar observation, where the surrounding temperature is 100 degrees centigrade, which is higher than the melting point of naphthalene. The transition time of 30 grams of naphthalene is 12.156 seconds when the surrounding temperature is 100 degrees. The curve remains flattened in the transition time. The curve remains flattened for 12.156 seconds and during the temperature 101.6 degrees centigrade. It is called the equilibrium temperature.
Now let us draw a table to take down values of temperature and transition time by keeping the mass as constant. That is 10 grams, 30 grams and 50 grams. The graph between temperature and transition time of 10 grams mass. As we can see, its temperature increasing as transition time is increasing. Graph is also increasing with the temperature. It's similar to the graph of 10 grams mass. Okay, coming back to observations and conclusions which are made by performing this given experiment. First, we can observe that as we keep on increasing temperature, by keeping the mass constant, we can find that even the transition times also get increases. Transition time is the time which the graph gets flattened. During that time, there would be no change in temperature. It is generally the time where the substance changes its state. In our case, it is the temperature of melting point 80.26 degrees. But the case is different when we take the surrounding temperature in such a way that it won't touch the melting point. It is 100 degrees Celsius in our case. During the 100 degrees Celsius, the transition time is equal to its equilibrium temperature, where the graph will be flattened and more than it is more than for 12 seconds. I have also noticed that as we keep the mass constant and increasing the temperature, the time to reach the transition state decreases. But if we take the temperature as 100 degrees Celsius, the timer won't stop because whole substance won't change its state. If we keep the temperature constant and change the mass, we can find transition time increases a little bit. The change is practically very small, which can be very negligible. Naphthalene changes its state from liquid to solid after it reaches 80.26 degrees Celsius, which is the melting point of the naphthalene. We can get accurate results if we take temperatures between the 0 and 25 degrees Celsius. Let us see a table which defines as the transition time taken by a substance. By 10 grams of naphthalene substance, we get 6.570 transition time. By 30 grams of naphthalene substance, we get 6.582 seconds transition time. And by taking 50 grams of naphthalene substance, we get 6.585 seconds. Now let's see the tables and graphs belongs to this. See the graph between the mass and the transition time, which was defined in the last table. Okay, here we have found the value of K for naphthalene by using Newton's law for cooling. Uh, by calculating the value of K of naphthalene, we have found that the value of K is 0.31173 minute inverse. I have verified this result by taking different masses and different temperatures also. Now let's calculate error obtained in taking mass. The observed was 10.002 grams and the calculated is 10 grams. So the error can be obtained by subtracting them both, which is 0.002. The fractional error is 0.002 by 10, which is 2 into 10 power minus 4. So the percentage error is 0.02 percentage. Error obtained in taking temperature. The observed temperature is 25.05 degrees Celsius and the calculated is 25 degrees Celsius. So error can be obtained by subtracting them both, which is 0.05 degrees Celsius, and the fractional error is 0.05 by 25 degrees Celsius, which is equals to 0.002 degrees Celsius. So the percentage error obtained in taking temperature is 0.02 percentage. Even if we take utmost care while performing experiment, there might be errors due to like clicking of stopwatch, due to rounding of numbers, and even if the weighing machines might be damaged or not accurate, there might be limitations due to lab equipments and so on. Hello. Now let's come to the second substance. The second substance name is wax. We have taken 10 grams of found wax and found the transition time for different temperatures like 0, 25, 50, 90. After noting down the all transition times of same mass, we have changed the mass to 30 and 50 grams and found out the values for 0, 25, 45, 90 degrees centigrade. The naphthalene I have taken is in liquid state, which is at 208 degrees Celsius. Hello. Firstly, I have taken the mass of substance as 10 grams and the surrounding temperature as 0 degrees Celsius. And the transition time of 10 grams of wax is 6.882 seconds when the surrounding temperature is 0 degrees Celsius. The curve remains flattened within the transition time. Here we can see the curve. The curve becomes flattened at this point, and the melting point I got is 45 degrees Celsius. Now I have kept the mass constant, but I have changed the surrounding temperature as 25 degrees Celsius. This time the transition time of 10 grams of wax I got is 7.77 seconds. When the surrounding temperature is 25 degrees Celsius, the curve remains flattened in the transition time. As we can see here, the curve becomes flattened at nearly 50 degrees Celsius because the melting point we got is 45 degrees Celsius, which is near to 50 degrees Celsius. Now I get the surrounding temperature as 45 degrees Celsius and same the mass is as constant. This time the transition time I got is 8.67 seconds and the melting point I got is 45 degrees Celsius. This time I kept the surrounding temperature as 90 degrees Celsius and as same as the mass as 10 grams. Now I got the transition time as 11.718 seconds. Here we can see the graph is flattened at nearly 100 degrees Celsius. Yeah, the melting point I got is same as 45 degrees Celsius. We have taken the mass of wax as 10 grams only. Now let's take mass as 30 grams and the temperatures as 0, 25, 45 and 90. Here I have taken the mass as 30 grams and surrounding temperature at 0 degrees Celsius. The transition time of 30 grams of wax is 86.884 seconds when the surrounding temperature is 0 degrees Celsius. The curve remains flattened in its transition time and the melting point I got is 45 degrees Celsius. Now I have taken the surrounding temperature as 25 degrees Celsius as well as the mass remains constant. This time I got transition time as 7.778 seconds when surrounding temperature is 25 degrees. The curve remains flattened at its transition time. The melting point I got is 45 degrees Celsius. This time I have taken the surrounding temperature as 45 degrees Celsius and the transition time I got is 8.678 seconds. The curve remains flattened in its transition time. The melting point I got is 45 degrees Celsius. This time I am taking the surrounding temperature as 90 degrees Celsius as well as we are here taking the mass as constant. The transition time of 30 grams of wax at 90 degrees Celsius I got it 11.720 seconds. The curve remains flattened at its transition time. The melting point I got at this time is 45 degrees, which is same as before.
We have drawn the table for different masses at different temperatures. We can observe that as we increase the temperature higher, we can observe the transition time also gets increased. And also, we can observe there is slight increase in the transition time as we increase the mass of the substance. Let us see the table for 50 grams substance. After seeing the table of 50 grams substance between the temperature and transition time, I can see that there is no such vast increase between the 30 grams and 50 grams. The transition time is increased by 0.01 second. Also, we can observe there is increase in transition time as we increase the temperature from 0 to 90 degrees. We have plotted a graph between temperature and transition time for 10 grams of naphthalene. We can see as we increase the temperature from 0 to 90 degrees, we can see that there is increase in transition time from 6.82 to 7.77 to 8.67 and 11.718 seconds. We have also plotted a graph between temperature and transition time for 30 grams of naphthalene from 0 to 90 degrees centigrade. We can see as we increase the temperature from 0 to 90 degrees centigrade, there is increase in transition time. We have also pointed out the error using these white lines. Let us plot a graph for 50 grams of naphthalene. After plotting the graph for 50 grams of naphthalene between the temperature and transition time, we can conclude that even there is increase in transition time for not only increase in temperature but also increase in the mass of the substance.
Here the observations and conclusions are made by performing the given experiment. We can observe that as we keep on increasing the temperature by keeping the mass constant, we can find that even the transition time also increases. Transition time is the time which the graph gets flattened, and during that time there would be no change in temperature during that time. It is generally the time where the substance change its state. In our case, it is the temperature of melting point 45 degrees Celsius. But the case is different when we take the surrounding temperature in such a way that it won't touch the melting point. It is 90 degrees centigrade in our case. During the 90 degrees centigrade, the transition time is equilibrium temperature, where the graph will be flattened for more than 11 seconds. I have also noticed that as we keep the mass constant and increasing the temperature, the time to reach the transition state decreases, but if we take the temperature as 90 degrees centigrade, the countdown timer won't stop because whole substance won't change its state. If we keep the temperature constant and change the mass, we can find transition time increase a little bit. The change is practically very small, which can be negligible. Wax changes its state from liquid to solid after it reaches 45 degrees centigrade. If we take temperatures between 0 to 45 degrees centigrade, we can get accurate results. When we take mass 10 grams, the transition time 8.670 seconds. When at 30 grams mass, the transition time 8.678 seconds. At 50 grams, the transition time 6.679 seconds. The mass versus transition time graph. Here we taken mass 10, 30, 50 grams. When the graph plotted, the transition time increases when the mass also increases. But there is no massive change. It only increases slightly, as you can see. The rough work done to find the value of K for wax. Here we taken the Newton's law of cooling formula and done the calculation. We got K value. By calculating the value of K of wax, we can find the value of K is 0.225 by minute. I have verified the result by taking the different masses and temperature. Error calculation in mass. Here we taken mass value 30 kgs, least count value 1 milligram, observed 30.002, calculated value 30 kgs. Error is equal to observed value minus calculated value. Hence we done the calculation, we can find out fractional error and percentage error. The fractional error obtained in taking mass is 0.0006. The percentage error obtained in taking mass is 0.006%. Error in calculating temperature. The taken temperature is 50 degrees centigrade, least count is 0.5 centigrade, observed value 50.5 degrees centigrade, calculated value 50 degrees centigrade. Hence we done the calculation. The fractional error obtained in taking temperature is 0.01. The percentage error obtained in taking temperature is error analysis. Errors are common when we perform any experiment. There would be error during the clicking of stopwatch. There would be an error in calculating the value of k due to rounding of the numbers. I have also mentioned the error limit while drawing the graph. There could also be an error in mass of substance due to limit in weighing machine. There could be also be an error in measuring the temperature of substance due to the mercury level of lab. Thirdly, we have taken 10 grams of ice and found out the transition time for different temperatures like -10, -5, 30, 70 degrees centigrade at 10 grams of mass. After noting down all the transition times of same mass, we have changed the mass to 30 grams and 50 grams and found out the values for -10, -5, +30, +70 degrees centigrade. The ice or water have taken is in liquid state. At here the experiment done in Amrita lab. Here we take the mass at constant 10 grams, the surrounding temperature -10 degrees centigrade. When we run the experiment, we got the result transition time of 0.3865 minutes and a melting point at 0 degrees centigrade. The transition time of 10 grams of ice is 23.19 seconds. When temperature is -10 degrees, the curve remains flattened in transition time. Keep, Keeping the mass of substance constant at 10 grams, the surrounding temperature changing to -5 degrees centigrade. When we run the experiment, the result we get transition time 0.4049 minutes and melting point at 0 degrees centigrade. The transition time of 10 grams of ice is 24.294 seconds when surrounding temperature is -5 degrees. The curve remains flattened in keeping constant mass 10 grams and changing the temperature to 30 degrees centigrade. When we run the experiment, we got transition time 0.6074 minutes and melting point 0 degrees centigrade. The transition time of 10 grams of ice is 36.444 seconds. When surrounding temperature is 30 degrees, the curve remains flattened in the transition time. And also changing the surrounding temperature to 70 degrees and run the experiment, we got the result transition time 1.4172 minutes and melting point 0 degrees centigrade. The transition time of 10 grams mass of ice is 85.032 seconds. When temperature is 70 degrees, the curve remains flattened in the transition time.
Now let's go with 50 grams of ice and with various temperatures like -10, -5, 30 and 70 degrees centigrades. Here the mass of the substance is 50 grams. The substance is ice and the surrounding temperature is -10 degrees. Here the transition time is 0.3866 in minutes and 23.196 in seconds. And the curve remains flattened in the transition time due to no heat being released into the atmosphere, and itself uses the heat to change its state. And the mass of substance is 50 grams here, and the substance is ice, and the surrounding temperature is -5 degrees Celsius. The transition time is 0.4050 in minutes and 24.3 in seconds. Of ice is 50 grams and the surrounding temperature is 30 degrees Celsius. The transition time is 0.6075 in minutes and 36.45 in seconds. 50 grams. The surrounding temperature is 70 degrees. The transition time is 1.4174 in minutes and 85.044 in seconds.
Let us draw the table again is the temperature and transition by keeping the mass constant at 10 grams and 30 grams mass. The temperature at minus 10 degrees centigrade, the transition time is 23.19 seconds. At minus 5 degrees centigrade, the transition time we found 24.294 seconds. And also at 30 grams mass, the temperature at minus 10, we get the transition time 23.194 seconds. At minus 5, we got transition time 24.296, and you can also able to see 30 degrees centigrade and 70 degrees centigrade transition time. And also at 50 grams mass, the temperature and transition times table we can see at minus 10 degrees centigrade, the transition time we get 23.196 seconds. At minus 5, transition time 24.300 seconds, and so on. The temperature versus transition time graph at 10 grams mass. Here we can see the temperature we take minus 10, minus 5, 30, 70 degrees centigrades, and transition times from 0 to 90 seconds. Here when the temperature increases, the transition time also increases, as you can see. Here the graph, the temperature versus transition time at 30 grams mass. Here also same. The graph increases when the temperature increases, the transition time also increases. At 50 grams also, the temperature versus transition time. When the temperature increases, the transition time also increases, as we can see in the observations and calculations.
These are observations and conclusions I made by performing the given experiment. We can observe that as we keep increasing the temperature by keeping the mass constant, we can find that even the transition time also increases. The transition time is the time which the graph gets flattened, and during that time there would be no change in temperature during that time. It is generally the time where the substance changes its state. In our case, it is the melting point, but the case is different when we take the surrounding temperature in such a way that it won't touch the melting point. It is 30 degrees and 70 degrees in our case. During the 70 degrees, the transition time is the equilibrium temperature where the graph gets flattened more than 85 seconds. I have also noticed that as we keep the mass constant and increasing the temperature, the time to reach the transition state decreases. But if we take the temperature as 70 degrees, the countdown timer won't stop because the whole substance won't change its state. If we keep the temperature constant and change the mass, we can find the transition time increases a little bit. The change is practically very small, which can be negligible. Ice changes its state from liquid to solid after it reaches 0 degrees. If we keep the temperature between minus 10 and 0 degrees centigrade, we can get accurate results. By seeing the below table, we can guess that there is no such big increase in the transition time as we increase the mass of the substance. We have plotted a graph between mass and transition time, where we can see there is increase in transition time from the 10 to 30 degrees and 30 to 50 degrees. But the change is very small, which is 0.06 and 0.06. Out of curiosity, we have found out the value of K for ice. By calculating the value of K of ice, we can find the value of K is 0.0557 per minute. I have verified the result by taking different masses and temperature. Now I request Gautam to continue with the error analysis.
The error obtained in taking mass. The observed mass is 50.004 grams and the calculated is 50 grams. Error can be obtained by subtracting them both, which is 0.004 grams, and the fractional error can be obtained by dividing the error with the calculated mass, which is 0.08 percentage. Let's find the error obtained in taking temperature. The observed temperature is 30.5 degrees Celsius and the calculated is 30 degrees Celsius. Error can be obtained by subtracting them both, which is 0.5 degrees Celsius, and the fractional error can be obtained by dividing the error with the calculated temperature, that is 0.0166, and the percentage error is 1.6%. No matter how good we perform the experiments, there may be errors due to late clicking of stopwatch, due to rounding off of numbers, and even the weighing machine might not be accurate or might be damaged. There might be limitations due to the laboratory experiments and so on. In order to succeed, innovations lab require a clear purpose that will empower the parent organization, a portfolio of beacons projects that push the edge of the organization's current strategy, creative teams with a breadth of expertise, and workspaces where the lab can develop and sustain its own unique culture. The process followed is initially we thought of doing a PPT. I mean the basic structure of PPT and initial ideas. I mean how to do, and the team used to do the thing and everything. And the second is performing the experiment with the team and taking the observations and plotting the graphs. And the last and the next step is making a video of PPT and clearly explaining the experiment so that everyone can understand it. Out of curiosity, we dug deep into the experiment and explored the different observations, more than the aim of the experiment. This tells us not only to perform the experiment, but to learn something that other than the aim of the experiment, just to think out of box.
Here's the team who involved in the experiment and presentation. First of all, the Kadali Sri Akash, who gave the idea of PPT format, and Vishnu Swarup, observation and calculation analysis, and K. Gautam, who gave the best PPT design and presentation, and Tarun Kampati, verification and testing of obtained values.
Total of 6 Google Meets, and the first one was on Jan 24, and which was held due for the thinking of idea and performing the experiment. And the second was on Feb 7th to execute the idea we thought and selecting the templates. And the third one on Feb 14th, and to perform the date we have fixed a date for performing an experiment. And the fourth one on Feb 21 to plot the graphs, and on fifth one on Feb 26 to put all the observation and finalizing the PPT, and on Feb 27 to make the video of PPT and brushing up at the final.
Here are the credits to get. First of all, we would like to thank our beloved Professor P.K. Ahluwalia sir for giving us such a wonderful opportunity for working as a team. And we would also like to thank Amrita Lab for helping us to get the experiment of laboratory events by sitting in home. We'll have learned the process of teamwork. We would also like to thank Shipra Madam for helping through a doubt solving session.
Thank you very much, sir, for giving us such a wonderful opportunity to work together.